Thank you so much, Ali, and all the hosts for arranging the conference. My name is Asad Khattak. I'm a professor at University of Tennessee in Knoxville. Before that, I used to teach in Virginia at Old Dominion, and before that, I was at Chapel Hill in North Carolina. So it's like coming back um, to home state. In fact, when I was, this was in the 1990s, I worked with two professors here at NCANT. One was Ryuichi and Sakano, and also Julian Benjamin. So my relationship with this university goes back to the 1990s. And so in this project, we want to talk about how our framework that we are developing for assessing readiness is taking new ideas and transforming them and customizing them to the rural context. So we'll show you some of the AI techniques that we've used for text analysis and synthesis of the literature. There isn't that much literature, but I think there is enough that we can gain some insights from it. So one thing that we've looked at is what are the leapfrog technologies that we can use? So leapfrog is something that one can think about in developing countries. A lot of leapfrog happened when we had phone access. That is, many countries didn't have huge landlines for telephones, and they switched over to smartphones. And the infrastructure allowed them to kind of leapfrog that landline infrastructure. Similarly, can we do this in the rural context with the new technologies that are emerging? And this is, I gave you the cell phone example as just one example, but there are several other examples. For example, microcredit. Microcredit was empowered women in Bangladesh. That's where it started, where women were giving small loans and also access through cell phones, and they were able to generate much more economic growth and empowerment of women happened in that context. So there are studies and examples from which we can learn. In the case of our investigation, we looked at this hype cycle, Gartner hype cycle, which actually does look at emerging technologies that are on the horizon. So, they talk about hype in cloud computing, and all of us are enamored with generative AI. And also they talk about causal AI, which helps us focus on the causes of what is going on and develop a deeper understanding of what kind of models might be better and deeper and able to be more robust. Also, they talk about within machine learning, this RL, reinforcement learning, and cybersecurity, of course, has also gotten some hype. So if you look at the top of the hype cycle, sorry, it's not extremely clear here, but it, the generative AI seems to be one of the areas where we are seeing a big hype right now. And then it goes through this trough of disillusionment and then the maybe some slope of enlightenment, as they call it. So this is a good example of how we can think about leapfrog. Also, application areas from past cycles, and they update this every year. So this automated vehicles, 5G communications, electric vehicles, those are all examples from past hype cycles that are maybe on the plateau of productivity, or maybe they've gone to the slope of enlightenment. So we looked at about 20 studies. I can show you the Prisma graph, but for now, for brevity, we've focused on urban areas and also looking at rural areas. So we didn't have too much information from the rural areas. About 20 studies we were able to find, about 40 for urban areas that were relevant. But as you can see, in urban areas, people are talking about communication, but for rural areas, a lot of it is more talking about the system, but technology in particular, and maybe not so much about communication. So we think that might be a gap in this whole process. In addition, we looked at phrase plots, and in rural areas, I was a bit kind of pleasantly surprised that rural is, transit is considered pretty highly, at least in the literature. In urban areas, people are talking about more edge computing and automated vehicles and so on. But in rural contexts, that's what we find. So there's a lot more information I can share with you, but in the interest of time, we will proceed quickly. So within the text mining results, what we see is one method is topic extraction, and we are able to see that there's, the topics being discussed more objectively include the non-motorized travel, and then also transit, again, dedicated short-range communication. This is kind of FCC is kind of doing away with DSRC and moving more to 5G, digital infrastructure, and also cyber infrastructure as well, which are kind of the same things, and medical care being important within these contexts. One thing which we did, also you can do link analysis of the information that's contained within those papers and reports. And one thing, of course, we found was this precision agriculture. People are talking about how in rural areas we can improve agriculture. But again, broadband is the enabling technology, as was mentioned, which is extremely important. And we are also, we currently have funding for all this, as was mentioned in the beginning. So this is what people are talking about within the literature, excuse me. And then again, transit and so on. So we looked at this, and based on my previous study that I did for Department of Transportation, Tennessee Department of Transportation, we are able to divide things into maybe different aspects. So some of it is physical and digital infrastructure. And this could include smart cities, and we are talking about smaller smart cities at a maybe rural or small city level. But we also need to have proper regulation and policy. We need to have also public acceptance of new technologies or new ideas or new innovations. And we need to have also infrastructure that kind of is a combination of physical infrastructure as well as digital infrastructure, which would be an electric charging station. So this is a kind of a conceptualization that we think is important, and it's applicable within the rural as well as urban contexts. But the point is that we can have some investment in the future of this mobility using some of this framework that I'm pointing out here. The strategies are meant to lead us toward achieving equity and also economic development, safe mobility, and other aims. One thing which many people are talking about are these revolutions that we think are happening, which is automation, connectivity, electrification, and shared mobility, called ACEs, within a multimodal context. So that's what the idea is. I won't go into details of this, but I think it's becoming more and more clear that we need to have all of these elements, whether it's rural or urban areas. We need to have this ACEs kind of framework, and it applies to the movement of both people and goods. We, as Jerry mentioned, we have been working on looking at how this framework can be customized to the ACEs idea. So what I presented previously is a very generic kind of a framework, but the good thing is that we do have the invest tool, where we can operationalize some of these ideas that we have in terms of developing the framework and establish support and pilot programs, for example, for fiber internet communication and data and dashboards that are managing the system. So basically, this example shows us how we could have a regulatory structure and weight it and give a readiness score for it. And you can calculate an overall readiness score. I won't go into the details of it. This criteria we can change, but idea is that we will have for each area a readiness score, and that would dictate whether what kind of investments they may need in the future to get at a higher and higher level of readiness. So that's the basic idea here. We are operationalizing our framework into support services, cybersecurity are common, but if this one shows more electric vehicle, on this side we are showing more automation. So one other thing that I want to point out, which has to do with analysis, is this database that has been released by the US DOT. It's called the Justice 40. It has been very helpful to us in terms of looking at disadvantaged communities, and they have all these measures that are related to transportation disadvantage and environmental disadvantage and resilience disadvantaged communities. We looked at this in the context of safety and developed some models looking at how these different indicators are correlated with safety. And indeed, what we found was that disadvantaged communities are at a much higher risk. And also that in terms of disadvantage, if they have a higher health disadvantage, then we do see more crashes in those communities. This was done at the census tract level. And also another important aspect is what the concept of heterogeneity. So, as we know, the effect of some factors are that is, some interventions or strategies that we may implement may vary. And this points out that we need to have very targeted kind of strategies, because sometimes we are able to see a bigger effect of a particular intervention in some areas than other areas. So that's the idea that we are able to, with new kinds of methods, we are able to tease out that information and see where a particular intervention would have a stronger effect. So that's the idea here. And we're looking at the Southeast region and tracts and what the transportation cost burden is in rural areas, and especially in disadvantaged rural areas. These are just some of the data that we are using. There are 17,000 census tracts that we are analyzing, and we are looking at in addition to poor mental health or traffic fatalities and so on, we are looking at other socio-demographic variables as well. And as you can see, just to give you an example, the simple models that we have used, and these are pretty good models. In terms of transportation cost burden, we find a very strong correlation with % of households with no internet subscription. And we see the positive sign means that we are more likely to have a higher cost burden if there is no internet connectivity. So this points out to all the things that we need to be able to do within the context of this project. Main thing I want to point out is that there are economic disadvantages which can be addressed with better, more connected services, which there are also social connectivity advantages that come with this kind of broadband access. Broadband can be brought to rural areas using mesh networks or low satellites and other kinds of more creative leapfrog type technologies. So we are exploring those leapfrog technologies, innovative technologies. We are looking at diverse databases, which include this equity database, for example, which is integrated, and we can visualize things in terms of how much each area is ready for what kind of technology. And also, I showed you some simple examples of modeling, especially heterogeneity. That is, these effects can be different spatially, and we need to be able to account for that. Our collaboration with NCNT and FAU is going very well, and we are preparing some papers for TRP to go after in this coming year. So I think we are, doing a lot of good work on just looking at this problem of rural areas and how we can leapfrog. So thank you.
So, Dr. Khattak, you mentioned that the leapfrog technology, but how do we evaluate that we work before you propose, or what is the basis of the analysis? For the leapfrog, are you just identifying the technologies, or is there a way you can, so those are not there, right? It's coming. So how are you evaluating those?
Right. So, so these technologies, obviously, Ronnie, are for now we are identifying what are those leapfrog technologies, and through our readiness framework, we will be able to assess the initial case study. So there's a method called case-based reasoning. Now that you asked me this question, so if a technology hasn't been tested yet or hasn't had a strong impact, but it only has been tested within maybe laboratory conditions, or maybe a little bit of simulation, or maybe a little bit of field test, then the question is, how do we transfer that knowledge into a broader implementation? And there are methods that we are thinking about, like case-based reasoning, where you can look at that limited piece of information, or even Bayesian methods will help you create data from within the limited data that you have for such technologies. And that would be the idea, that we would be able to implement all this within this context, taking into account how much ready that particular technology is for implementation within a very specific context. So we are trying to match as much as possible within the heterogeneity, as well as looking at the impact. So I hope I answered your question.